standing there, and the number of bikes and cars will go straight in the road. Whenever this pattern matches, what pattern? First, bike should go, then car should go, then bike and bike should go. So then you're detecting the pattern. You're not owning. This pattern is matched, so that you're writing one. In throughout the day, from morning to the evening, 6 a.m. to 6 p.m., you are checking this pattern. Correct? Then you will be getting, suppose this pattern matches for 50 times or 100 times. You're not owning this. So manually, this takes what? Manual. Usually manual, humans are prone to the errors. Suppose you miss somewhere. If that pattern misses, what happens? Is more prone to the error, right? Then how to make this as an automation? This is what state machines comes into the picture. Any requirement, making it into what? Automation. Your elevator operation, your refrigerator, your traffic light signal. Right? Earlier, way back to 30, 40 years back here, there is no traffic light control. Signals are not there. Humans are used to stop the vehicles. Now we came up with the traffic light control. Right? So one example that if human is measuring this pattern from 6 a.m. to the 6 p.m., maybe there is a more time consuming one thing, but and then more prone to the error. Then how to do this is then now from the point to 6 a.m. to the 6 p.m., my sensor will detect all the one. This car bike and car bike, whatever this pattern it is one. If this pattern matches, so I induce the output as one. Now we can make a one counter. Once this pattern matches, we can increment the counter. So that I can completely manually, which is more prone to the error, I can do that using what? Using the same machine I can build this. You don't understand. What is the use of the pattern detector is nothing but whenever this pattern matches, I need to detect this. The use of this is nothing but I'll be understanding that what is the frequency of cars and bikes is flowing in this road by taking this analysis, correct? If this pattern matches most to one. Bikes only, right? Both bikes are there in this pattern. If there are a number of counts increases, I will use this data. Some sort of this, my sensor will use this data. This data is used to analyze what is the frequency of bikes is going, what is the frequency of cars is going. You understand? So there are many use cases of the pattern detector. That's why in the state mission most of the time. So we used to develop a pattern detector. This pattern detector is used in many applications. Okay. Now I want to detect this pattern. So let us take an example. This is my state mission. I developed the state mission. This is a state mission I developed. This is the input I'm giving X. X is the input, let us take. Z is the output. Since this is a sequential logic circuit, we have a clock also, right? Clock. Now I'm giving very long length sequence to this. You understand? Means what I'm getting here? 1010 means what is bikes and cars. This type of bikes, cars are going in the road. Now whenever this pattern matches, now what I need to do? Detect this pattern. Are you understanding? This is what this state mission includes the sensor. Okay, when car detects it gives 0. When bike detects it gives me the 1. And then I should develop a hardware that once this pattern matches. So here pattern matching here. 101 is pattern matching here. Again where another pattern matches here. Here 1011 pattern matches here. Again where another pattern is matching here. Again where the pattern is matching. If I'm talking about again pattern matching at two times. One is overlapping and non-overlapping. So if I write this pattern for the non-overlapping. Okay, let me write. What is the pattern is 1011. This is a long length sequence I'm going to give like this. Now can you detect the pattern? The pattern I've given is this one. Can you detect the pattern without overlapping? Without overlapping. What is the pattern? 1011. What is the output of this pattern detector output? Now once you detected one, is it you completely detect the pattern? No, right? How many bits I have? 4 bits. So this is the output of non-overlapping. If I'm right about non-overlapping. So what is the output is 0, 0, 1. This pattern matches here. I'm coming from this side. So I'm taking this as this MSPBT. In this case, this MSPBT, this LSPBT. So for this my state mission, I'm giving from this as the first input 1. The next I'm giving what? 0. Next I'm giving what? 1. Next I'm giving what? 1. Do you understand? If I give this pattern to my state mission, whenever this pattern matches, what it should happen? My pattern should be detected so that Z becomes high. It's logic 1. Again, where the pattern matches here? Overlapping, non-overlapping at all. Now this is the one pattern matches here. If I take this one, again there is a pattern matches here. Right? But what I'm talking about here? Non-overlapping. Therefore, this is output is 0. Right? 0, 0, 0, 0. Again 0, 0, 0, 1. This pattern is matching here. Again next is 1. 0, 0, 0, 0. Again 1. 0, 0, 1. The pattern is matching here. Next is 1. 0, 0, 1. This pattern matches here. Right? Again what is this? 0, 0, 0, 0, 0. This for what is? Non-overlapping. Same thing if I'm asking you to do overlapping. Overlapping. Can you write the overlapping output? Overlapping output. The overlapping output. 0, 0, 0, 1. Again, there is if I'm overlapping this field. I can match my pattern. Now this is what? 0, 0, 1. Next is 1. So here 0, 0, 1 is right. Again 1, 0, 1, 1. No, right? 0, 0, 0, 0, 1. This pattern is matching here. Again, there is a pattern is matching here. Again 0, 0, 1. Again what? 0, 0, 0, 1. Again, any pattern is matching here. No, right? Again 0, 0, 1. One more pattern matches here. If I go to the overlap. 1, 0, 1, 1. Right? Now this is 0, 0, 1, 0, 0. You understand? So this is a pattern detection of non-overlapping. This is a pattern detection of what? Overlapping sequence. Overlapping sequence. So explicit state machines are two types. One is Mealy model and Moray model. Mealy model output depends on the present states and the present input. Explicit Mealy model. Moray model is output depending only on the current states. Correct? You understand? Now can you write a state diagram to this pattern detection? I want to detect this pattern. Can you write a state diagram? How to write a state diagram? Write a state diagram. What I was asking here. Yeah. State diagram for this pattern detection. 1011. Using what model? Using Mealy model. Using Mealy model to write a state diagram for non-overlapping. Let us take the non-overlapping. Non-overlapping. How to write a state diagram for the non-overlapping? What is the first initial state is? This is the state. Initial state, start state, right? So initial state I can call GN state. For this pattern selected GN means what? Got nothing state. For your understanding, let us write like this. GN indicates what? I have not got anything. Got nothing. Got nothing state. Means this is the initial state. Usually initial states are represented like this, arrow mark. Or they will put what? The concentric circles like this. In your state machine, if you find the symbol like this, or if you find the what? Concentric circles like this. Correct? If you give a state machine, you should know that where your initial state is there. Correct? So if you find like the arrow mark like this or a concentric circle like this, that indicates what? It is a reset state or initial state or a start state. Or a ideal state. Many names you can call. You understand? Now I have to write it for Milley model. What is a Milley model? Is where output is depending on what? Only the output is depending on the present state and the what? Present inputs. Now first initial state is nothing but what? Dot nothing state. So this arrow indicates it is the initial state. So dot nothing state indicates that I have not received any pattern. I have not detected any pattern. You understand? If dot nothing state receives 1, which state it is going? Next state. This is what state diagram. State diagram is a diagram which gives the relationship between one state to the next state. Now if dot nothing state receives 1, it is going to what state? It is going to the next state. The next state shall represent what? Got one state. Now I got one. This is the pattern I want to detect. This is I have got one. Correct? Then how to write the model, state diagram for the Milley model? This is if I'm taking this is X is the input. X is the input. Milley model output is depending upon what? Present state, present state and the input. So I can write that this is my Z is output. Z is output. Output is depending upon the what? Present state. This is my present state. This is nothing but what? Input. X is equal to 1 means what? Input. Z is the output. Output is depending upon the present state and what? Present input. What is the Z output? 0. Why 0? Pattern is not detected. Still you detected what? Only the 1. Therefore output is nothing but 1. 0. So if you write 1 by 0, this indicates what? Your Milley model. Here 0 indicates what? Output. 1 indicates what? Input. Output is depending upon the present input and the present state. Now once you detect the 1, what is the next bit you need to detect? 0. Got 1 state, detects 1. Which state it is going? Next state. What is next state representation I can do? Got 1 0 state. J10 state. What is J10 state indicates? 1 0 I have detected. When? Input X is equal to 0. What is output is? 0. You understand? If got 1 receives 1 instead of 0, if it is 0, 1, first 1 I have detected. If it is after detecting 1, next bit what I need to detect? 0. If I detect 0, I am going to 1 state. Next state. Next state I am representing as got 1 0 state. If got 1 receives 1, then instead of 0 here, if I receives 1, which state it is going? Same state. Why same state it is? Already I have 1 detected. My pattern should start from 1. 1 0 1. 1 already detected. Next my intention is to detect 1 0. So it will be remains in the 1 same state. If I am going to the reset state here, what happens again? I should start from the 1 beginning. Since I already detected here, so that I will be staying in the 1 same state. So what is output is? 0. You understand? Now 1 0 you have detected. What is the next bit I need to detect? 1. If got 1 0 receives what? 1. Which state I am going? Got 1 0 1 state. What is output is? 0. You understand? If got 1 0 receives 1 0, is it going to the previous state? Or it is going to the same remains in the same state? Or it is going to the reset state? It will go to the reset state. Why? Pattern does not matches. My pattern does not matches. If pattern does not matches, what I'm going to do, I'll be going to what state? Reset state. When? When it detects 0. What is output is? 0. You understand? Pattern does not matches. I'm going to what? Got nothing state. Now how many bits you have detected? 1 0 1 bit. Next what bit I need to detect? Last one. If this detects 1, which state it is going? Next state. What is the next state is? I'm talking about non-overlapping. Non-overlapping I'm talking about. If I detect 1, which state I can go? It should go to the what state? Reset state. Now I detected my complete pattern. Correct? Now I detected my complete pattern. Detects 1. What is my output is? 1. Did you understand? When it receives 0, now my pattern detection has been done. Here it detects 1, here it detects 1 0, here it detects 1 0 1. If I receive input is 1, my output is 1. So then again I should start from what? Beginning. So I will go to what state? Reset state. If it receives 0, if it receives 0, any pattern is matching to this. 1 0 1 0, any pattern is matching here. This 1 0 is pattern matching, right? So I go to the what state is nothing but this got 1 0 state. When it receives 0, what is output is? 0. Did you understand? Now in this case, this is overlapping. In case of non-overlapping, once you detect the pattern, instead of going to the next state, you are going to what state? J1 state. The non-overlapping case. Right? Not understand? Not understand. Okay. Okay, let us do one thing. Let us take like this. CB, CC. Ones and zeros, I'm writing like this. 1 0 1 1. This is a pattern I want to detect. First state, I'm going to take it as what? Got nothing state. If got nothing state, is nothing but ideal state. If got nothing state receives a byte. Whether it is going to the next state? No, right? What is the one we need to detect? Path. If byte detects, it will be still remains in the one. Same state. I understand. If it detects what? Path. Which state it is going? Got a C state, right? Now we detect the C. In C, what do I need to detect? Once I detect the C, next what I need to detect? Byte. If I detect the byte, correct? I'll go to what state? Got it. So instead of this, let me write like the C only. Or like GC I should write. Like, okay, let us write GC. G indicates got. Now what we got here? CD. Once dot C gets the B, it is going to this state. Dot C gets the C. Same state. Why it is same state? Already C is detected. C is detected here. So again, go and start from the reset. It takes extra time, right? What I'm going to do, since I already detected, my pattern is matching here. Correct? C I have detected here, so that I'll be staying in the same state. Now coming to this, once you detect CB, what is next you need to detect is C. Once you detect C, which state you are going? Got CC state. CBC state. Got CBC state. Right? Now you are detecting here one, CB. If you get C, you are going here. If you get a B, if you get to B, CB is detected already. If you get to B, CBB is matching to my pattern. No, right? CBB is not matching to the pattern. So that what I'm going to do, I'll ask to what? To the reset. When it is receiving what? B. Now coming to CBC. So now this CBC is detected. What next time what I want to detect? See, once I detect C, where I should go? I can write output is 1. For all this what? Output is 0. For all this output is 0. Now I have detected what? CB, CC. Then I can go to what side? Reset state, nothing side. Now here, this is CB. CB, if I'm getting CB, again, here C, I'm going to the nothing state. If I receive CB, yeah, already I have detected here. CB, C detected in this state. If I get to B, right, where I can go? CB state, here, my pattern is matching here, right? So instead of going to the reset state, I can go to what state it is? CB state. How do you understand? This is for what? Non-overlapping. This is for non-overlapping. Non-overlapping. How to do the overlapping then? How to do the overlapping? Overlapping, what we did, overlapping. We are overlapping the bit right. Now once you detect the pattern, in the non-overlapping, you're going to the gardening state. In overlapping, what will you do? Go to the GC state. Did you understand? If this is C and what is output is non-overlapping, it is output is. Did you understand? So this is this blue color indicates what overlapping is. Overlapping, sorry. Right? It's not non-overlapping, overlapping. This black color indicates here one. Let me write this is a red color. This indicates what? Non-overlapping. Did you understand? This is a Milley model or Moray model. This is nothing but Milley model, where output is depending upon what? Present state and as well as the present. So I can write this is nothing but a Milley model. Right? Same pattern can you do it in the Moray model? How to write the Moray model pattern? What is the Moray model? Depends only on the present states. This is my pattern 0, 1, 1. Oh, sorry, 1, 0, 1, 1. Moray model I want to write. So first state I can take what? Got nothing state. Where output depends on what? Only present input. I can write Z here. Z is output. It's depending only on the present state, not on what? Present input. Got nothing state. Got nothing state. Output is depending only on the present input, not on what? Present state, not on the present. Did you understand? If it receives 0, it will stay remains in the same state. Output is also 0. If it receives 1, it is going to what state? Next state, what is next state is? Got 1 state. Got 1, we got the 1. What is output is? 0. Correct. Once you detect the 1, what is next you need to detect? 0. Got 1, detects 0, it is going to what state? Next state, what is next state is? Got 1, 0 state, what is output is? 0. Did you understand? Here, when it detects 1, got 1, same state. It remains in the same state. Right? When it detects 1, it is going to what state? Next state, 1, 0, 1 state. What is output is? 0. When it detects 0, is the pattern is matching with this? No. So that is going to what state? Reset state. Got 1, 0 detects 1. Which state it is going? Now it is going to go with what? 1, 0, 1, 1 state. What is the output of this? 1. Since we have detected the pattern. How do you understand? When it detects 0, this pattern, this state detects 0. So 1, 0, 1 is detected. What is the next time 1 detected? 1, 0. There is a pattern matching. 1, 0 pattern matching. Go to the what? This state. For this non-overlapping. Now we detected the what? Pattern. Right? So what is the next state I can go? For the non-overlap. Now complete pattern I will detect. What is the next state? Once I detected this pattern, where I can go? This completely I detected the pattern. Is it in reset state or I can go to that one state? So non-overlapping all my pattern I have completed. Right? Again I should start next state is 1. Which state I can go? You can go to what state? Reset state. What is the reset state or set state it is? When it is 0. When it is 0, I'll go to the what state? Reset state. When it detects 1. If it is 0, my pattern is not start from 1. Once I detected, my pattern is starting from 1, not with a 0. If I detect 0, I'll go to what state? Reset state. If I receive 1, got 1 state. For what lapping it is? Non-overlapping. If it is overlapping, once I detect the pattern, if it is 1, it is going to what state? Got 1 state. If it receives 0, what state I can go? Non-overlapping. If it is 1, it is going to the that 1 state. If it receives 0 in the non-overlapping, I go to what state? G1 state. For overlapping. Did you understand? So this is a Milley-Moray model pattern detector. Like this, you can take any combination of the pattern. Like I have taken 1, 0, 1, 1. You take 1, 0, 0, 1. Okay, 3, 1, 1, 0. R4, with 5, with any pattern you can take. So write the Milley model and Moray model. For this, we need to write a Whitlam program. Pattern detection. So I'll generate a random pattern. Long length sequence pattern will generate. So once this pattern matches, what I want to do? Output is equal to 1. Did you understand? You should know that how you can convert your problem statement or any requirement to the state machine. So if you are able to understand this conversion of this into the state machine, you can easily model. You write a Whitlam program for this. Okay. So we'll start how to write the Whitlam program in the next session to the finite state machines. Okay. Finite state machines are two types: implicit and explicit. So user is explicitly going to define the state is explicit state machines. This example for explicit. Right? I'm telling you, if x is equal to 0, you go stay remains in the same state, I will go to the next state. User, you have control over this. Control over the what? Implicit state machine. So So Millian model and Moore model comes in the one. Explicit statements. You understand? So we'll see, so example, some FSM of the pattern detector in the Rectangle program for the pattern detector in the next session. We'll take various patterns, how to write the program. So we'll start in the next session.